Welcome back, everyone. So in the first segment, what we did was we laid out the basic structure of the lab with all four departments. What we're going to do in this part two version of the lab is to try to label everything and see if we could start getting some stuff connected. So what I want to do is to count our segments. So this would be LAN 1, and we're going to put that over here to represent LAN 1. And we're going to put some data in there that represents IP address and subnet mask and gateway info and stuff like that. So that would be LAN 1. And going forward, over here would be LAN 2. Just do that. And again, over here, we'll put LAN 3. So we know which LANs we're talking about. And again, for LAN 4. And I guess the LANs that go from router to router, we'd call that LAN 5. Okay, LAN 6. And finally, LAN 7. That looks nice. Now we get to the fun part. So the fun part is to decide what IP addresses we're going to give to each of these LANs. So we know that we have one class C IP address, which is this 192.168.1.0 network, and we're going to split that up into several IP addresses. So let's review that quickly. So here we go. So an IP address has 8 bits. Let's say let's go 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 zeros. And what happens when you borrow bits is, let's say, for example, we are going to borrow 2 bits. So here we go. 1 bit, 2 bit, 2 bits. So borrowing bits, let's label that bit borrowing. Let's put a note to ourselves up here for bit borrowing. Okay, let's go over how that works. So the ones decide how many segments you could get when you borrow bits, and the zeros decide how many actual usable IP addresses you get when you borrow bits. And the way you do that is to the, let's use this sign. So you go 2 to the second, and that equals 4. So that will tell you that you would get 4 segments, and with the zeros, you count the zeros. So when you count these zeros, you get 6 zeros left. So 2 to the 6, let's say, equals to 64. And that will give you 4 segments of 64 IP addresses each. The only other thing of note to take into consideration is what will be your subnet mask, and usually that's 255.255.255.0, which represents 256 IP addresses. But in this case, since you're splitting up the IP addresses, you would have to change your subnet mask to tell the computer that you're not using all 256 IP addresses, you're only using a 64 IP address block. So the way you do that is, let's delete the 0, is to figure out what number you want to put at the end of your IP address segment. So the way you do that is by either A, adding up the values of these 2 ones. So in an 8-bit number that you have here, the first 1 is 128, and the second is 64. So if you do 128 times 64, let's bring that up. Sorry, not times, 128 plus 64, you end up with a value of 192, and 192 becomes the subnet mask. So let's put that in here. Let's see, so it's 1255.255.255.192, and that would give you 4 segments of 64 IP addresses each. 4 segments of 64 IP addresses each, using the subnet mask of 255.255.255.192. The other way to do it, and I have to give my friend Asia a shout out for that, is to take 256 and then simply minus the number of usable IP addresses in each segment. So let's see if we could do that real quick as a sample. So we would do 256, which is the standard number of IP addresses, 256, and then you would minus this 64 number because that's the usable IP number, and hit equal sign, and you see you end up with 192. So you could either add up the values of the bits, or you could subtract the number of usable IP addresses in each segment. So we're going to do that. So that's going to leave us with 4 segments of 64 IP addresses each. So let's label those 4 segments. So those 4 segments would go something like this. It would go from 192.168.1.0 all the way up to 192.168.1.63, and that would be your first IP address range. The second would be 192.168.1.64, and 1.64, and that will go up to, you just add another 63 to that, and that would go up to 192.168.1.127, and that would give you your second IP address range. The third would be 192.168.1.128, and that one would go up to, let's add another 63 to that, 192.168.1.191, and that would be the third block. And the fourth would be 192.168.192, and that one would go up to 192.168.1.255, and that would be all 4 of your IP address blocks. So for now, I'm just going to keep this over here as a reference. There we go. So let's see. Now that we have these IP addresses blocked out, what we want to do is see if we could use them anywhere else in our little program here. So let's see. This one we could use the 75 IP addresses is required for sales, and another 75 is required for marketing. So what I'm going to do, I'm going to take the first block of 64 IP addresses, and I'm going to use them for sales, which is this LAN 2. So let me just write that down. It's going to be 192.168.1.0, and that's going to go to 192.168.1.63, and that will give me a total of 64 IP addresses. All right, so we do it like that, And remember, the gateway for this one would be the subnet mask, I'm sorry, for this one would be 255.255.255.192. There we go. All right, how does that look? So LAN 2, 64 IP addresses from 1.1 to 1.63 with a gateway of subnet mask, of 255.255.255.192. That is good for that one. And we're going to do the same thing for let's see, for marketing. So we're going to come over here, we're going to dump this into marketing, but this time marketing is going to go from 1.64 all the way up to 1.127, and that should be our LAN 2. Perfect. Sorry, this is LAN 3. Okay, nice. I'm liking this. We could get rid of that. Okay, so here we are with our 2 IP segments of 64 IP addresses each, one for LAN 2, which is set here, one for LAN 3, which is set here. These departments, however, require 75 IP addresses, so somehow we have to get another 11 IP addresses here and another 11 IP addresses here. So what we're going to do is, since we've already used these 2 blocks, we're going to have to split the remaining blocks up in order to get the required number of IP addresses that we're going to need for here, for this 10, and for this 10. But also remember that these LANs up here also require IP addresses. So for this one, we're going to need at least 4 IP addresses for all these LANs up here. So when you go from router to router, you're going to need an IP address for the router name. You're going to need an IP address for the broadcast, and you're going to need an IP address for both sides of the router, one on the left side, one on the right side. So you're going to need 4 IP addresses each. So these, if you add them all up, would be the total number of IP addresses you would need. So in the next segment, we're going to continue further into breaking down the following blocks of IP addresses that we have remaining, and we're going to assign them to LAN 1, LAN 4, and LAN 5, 6, and 7. All right, I will see you guys in the next video.